Hello everyone, this is Raymond. In this video, I'm going to talk something about the basic application of normal distribution. So the first thing is definition. A continuous random variable x is said to follow a normal distribution with mean mu and variance sigma square if its PDF, which means probability density function, is given by this formula. We can write it as x follows normal distribution, which means that normal distribution is defined by its mean and variance. And the CDF, which means cumulative density function for normal distribution, is given by this formula. A continuous random variable z is said to follow the standard normal distribution if its PDF is given by this formula. We can write it as z follows normal distribution. As you can see, for standard normal distribution, its mean equals to 0 and variance equals to 1. And for any of the normal distribution, you can transform it into standard form, by this formula. Now let's look at a problem about normal distribution. Cells X follows a normal distribution with mean equals to 2.5 and standard deviation, standard deviation equals to 0.3. The first question is probability that cells exist 3. I strongly recommend you guys to draw a graph if you are not very familiar with normal distribution. You can draw a graph like this, and then we need to find the probability that cells exist 3. You can draw 3 here, and we want to calculate the probability, means that the areas here. So we can translate this sentence to P x greater than 3, right? In Excel, there is a formula for calculating the CDF for normal distribution, which is equals to norm.dist 3, mean equals to 2.5, standard deviation equals to 2.3, cumulative 2. Then we can calculate the areas of here. But now we want to calculate this area, so we just need to use 1 minus, and this is our result. The second question, probability that cells lies between 2.35 and 2.65. We can also use this graph to solve our question. We can draw 2 lines here, 2.35 and 2.65. So we can translate this sentence to P 2.35 smaller than x smaller than 2.65. For this question we can just we can see this. You can use the CDF of 2.65 and then deduct it by the cumulative of 2.35. Then we can get the area here. Okay, so equals to num dot this 2.65 2.5.31 minus num dot this 2.35 2.5.31, and result is here. The last question, sales level that has only 9% chance of being existed. We can go back to the graph. We want to calculate. So now here is 9%. And we want to calculate the number here. Okay? We go back to Excel. So there is a formula when we know the probability and then calculate the x, okay? Which is equals to norm.inf. And now we know this area is 9%, so the area here is 91%, right? 91%, and then 2.5, 0.3, then we can get the result 2190. That's all for this video. Thank you for watching. See you next video.